Factor the polynomial completely. If it's not factorable, write prime. Okay, we've got this polynomial. I'm noticing it has 4 terms. And so whenever it has 4 terms, I look at it kind of as 2 separate. I like to separate it like that because when we throw in parentheses, it could confuse us, but this is just kind of a way to separate them. So this first one, I want to look, is there anything I could factor out of xy plus 3x? Well, they both have an x, so I'm going to factor that out. It's basically like we're dividing both by x. So x will have y plus just 3. Now if we want to check if that's right, I can distribute this x back through. If I multiplied that through, I'd get xy plus 3x. And so we can see we did that right. Okay, the second one, no variables, but I do see they both are negative and they both are divisible by 2. So I'm going to factor a negative 2. So if I divide negative 2y by negative 2, I'll get a positive y. Divide a negative 6 by negative 2, I'll get plus 3. Something I want you to notice here is when we factor out a negative number, it will change both signs. So we factored out a negative 2, negative 2y became positive, negative 6 became positive. Another thing to notice is these both became y plus 3, and so that's a very good sign that we've done this correctly. So now we can kind of see we've got 2 terms. One term is here, they're all multiplied, so that's considered a term, and one term there. Notice each term has a y plus 3, and so we're going to factor out the y plus 3 from each term. Okay, now that I've factored the y plus 3 from this first term, I've got an x left. I've factored the y plus 3 from the second term, so I have a minus 2 left. So this is called factoring by grouping, where you just look at the first 2 terms and then the second 2 terms, factor the greatest common factor out of each, and then you can factor the binomial out.